What I'm going to do now is I'm going to give you a quick tour through the basic Java completable future features. And these are the ones that you get out of the box because of the fact that Java completable futures implements future. They are not at all the end-all be-all of completable futures. And to make the example a little bit more interesting, we'll be kind of talking through some code from the EX8 folder in my GitHub repository just to kind of show how things work. First thing to note is that completable futures supports the future API. It does that through the good old implements feature. So you can see completable future here on the right. Implements future, so it has the cancel, isCancelled, isDone, get, and getLong methods that are all available for users of completable future, just like users of future. As a consequence, you can block, do time waits, and poll. And here's a very simple example that we'll be talking about in more detail here shortly, where we're going to go ahead and submit something, and then we're going to get the result through a future that we get back here. You could also cancel and test a completable future to see if it's done. So you can say, is it done? Is it canceled? You could also attempt to cancel it. Oddly enough, and this is just wacko bizarre, if you try to cancel a completable future, then by default, it doesn't actually interrupt the computation. And I won't go through all the horrible reasons why that's the case. If you're curious about this, you can go ahead and take a look here at the completable future can't be interrupted link and understand why it works this way. But it's kind of weird. Of course, there's ways around this, but just be aware that cancel doesn't really do anything on a completable future. One of the main benefits that was added to completable future to enhance what you get out of the box with Java Future is to add a method called join. And this is really about the only thing that's part of the basic set of features of completable future that's actually useful to know about. So what is join and how does it compare to what came before? Well, join can be used to block awaiting the asynchronous results to be finished running by the thread that's processing the completable future. So it's basically a variant of get. So it behaves like get does without using checked exceptions. So as a consequence, you can write code like this. You can have basically a list of futures. You could turn that list of completable futures. You could turn that list of completable futures into a stream of completable futures. You could then use the map intermediate operation, and you could call the join operation. And what join will do in that case is it will go ahead and wait block for each of those completable futures to be done, and then it'll return the results. So if you had completable future to integer, for example, then you'll end up with a stream of integers after we get done with map, and they will all be complete at that point. And then we would collect those things up into a list. So you can use completable future join as a method reference in a Java stream. So it's nice and clean and syntactically succinct. We'll talk more about whether you should be doing this or not later, but syntactically you can do it. In contrast, if you tried to use get to do the same thing as join, it would be very ugly. And that's because get uses what's called checked exceptions, whereas join uses what are called runtime exceptions or unchecked exceptions. Java in its early days thought that you should use checked exceptions, and that turned out to be a horrible, horrible design choice. And there's been lots of things over time to work around that bad design choice. Fortunately, modern versions of Java fix this by doing things like using join instead of get. If you use get, you have to put a try-catch block in here, or you have to use what's called exception laundering, which is another option. You'll see some of my code does that, and it's fine. But I think you would agree with me that this code here is nice and clean, and it's preferable to this horribly ugly code, and it's also preferable to this somewhat awkward-looking code unless you know what exception laundering is. If you're curious what exception laundering is, it's not like money laundering. You won't go to prison if you exception launder. You can take a look at the Stack Overflow link. So bottom line is that join improves upon get. Strangely enough, though, or not, depending on your point of view, join has no timed variant. So there's a timed variant of get. You can see this right above the join method in the UML diagram. There's a get long time unit. That's time. That's as only block the client for that amount of time before returning, either with success or with failure. Join does not have a timed variant. May seem like an oversight, it kind of was an oversight, but then with later versions of Java, they fix it by adding asynchronous time handling stuff. So there's ways of dealing with this. It's just not quite the same way it's done with get. So it's a little bit weird, but you live with it anyway. And as I think I mentioned before, using the timed versions of get is almost always a bad thing to do. The other minor enhancement that I kind of glom together with the basic features of completable futures is this complete method. And as we mentioned before, you can use it to give results to a completable future when it's done. So here's an example. We kind of talked about this earlier. Now we can look at it in more detail. You make yourself a completable future that has no computation associated with it at all. It's just basically an empty future. It's got no future. And then we go ahead and we create a thread and we start the thread. So this thread is now going to run in the background doing something or other. And that will allow the calling thread, right, the one that called start, to go and do something else concurrently. So you can see at this point, this thread is going to do something in the background and then other stuff's going to go on in the foreground. Several things can happen here. Either the foreground stuff will finish, in which case we're going to go and wait for the future to be done by calling join. That's scenario A. And or the computation will be taking place in the background, and at some point when that thread is finished doing its thing, maybe it's multiplying numbers together, who knows what it's doing, it's going to pass a result to the completable future by calling the complete method on it. And when the complete finishes, then the thread, any thread that is blocked waiting for that completable future to be done by calling join, or get for that matter, will be able to return with the result. So that's the idea here. You can explicitly complete a future. And there's no easy way to do that with, you can explicitly complete a completable future. There's no way to do that conveniently with a non-completable future. You have to do other stuff. It's more complicated. So that's a nice little teeny-weeny enhancement that makes life somewhat easier. Here's another little cool trick you can do that's worth knowing about. In fact, you'll need to know this when you do your upcoming assignment. Here's a case where we make ourselves a field called 0, and we give it a completed future of the value 0. So notice there's a method called completed future. So if you say completable future dot completed future 0, that will give you back an object that's a completable future that's completed that has whatever value you give it. In this case, we give it 0. And then down here, if for some reason we just want to say future.complete 0.join, the call to join will not block because we have a completed future. It will just go ahead and return right away, which will have the value that we want here. And there's some good use cases where having constants with zeros in them that have been completed helps to simplify your code. And you will discover that when you write your implementation that's coming up for assignment 3. So that's the end of a quick overview of the basic Java completable future features. We'll look at an example here a bit more comprehensively in the next lesson. But the key point is that these are good things to know, you should be aware of them, but that's not why we're using completable futures.